All right, so now we're going to get into the research process. So as I mentioned, right, the philosophical kind of understanding of things informs our research process. How are we going to engage in research? What questions are we asking? And then, right, what questions are we asking? So that's ontology. And how are we going to learn about that? That's epistemology. So statistics, while yes, right, there's formulas and calculations and mathematical components, absolutely. Really, it's the foundation for what's called quantitative research, right? As we mentioned, and statistics is really the foundation of that because it allows you to understand the whys, right? To understand that if you read an article and it says the standard deviation is, the p-value is, you understand what that means. And we're going to develop an understanding of that. So it is important that we understand the research process and how statistics informs that or works with it. So the first step of asking of the research process is, you ask a research question or you develop an idea. What are you asking? What are you curious about? What do you want to know? And generally looking at relationships between variables. So one example could be, um, mm, at what rate do younger adults visit the doctor? Okay. Then you create a hypothesis. So if that's my research question, my hypothesis might be, I, you know, I hypothesize that younger adults will attend the doctor at a lower rate than older adults. Okay. So how am I going to collect my data? Well, I'm going to maybe I'll do it by survey. I ask a series of questions around age, race and ethnicity, gender, maybe sexual orientation, kind of foundational demographic questions. Then I would ask questions around, how many times do you go to the doctor? Do you see a specialist? Things like that. And those are all what's called variables. So I'm collecting data at that point. Then once I've collected all this data, I analyze it. I run a variety of tests, and we'll talk about what types of tests there are later in the semester. But for the purpose of this, you would look at what's called descriptive statistics and inferential statistics, and I'll explain that a little bit later. But once I've run these tests and I've analyzed my data, then I start evaluating my hypothesis. I look at the literature that that's existed before, and then I look at how my hypothesis holds up to the data. What is the data saying? And then is my hypothesis true? Like, is it aligned with what the data says? And you'll see that like a research paper when we talk about this in class, or when we talked about it in class, right, is similar because you have your introduction, which is where you would put your research question. You have a hypothesis, which comes from the literature and goes into your methods. You have your collection of data, which is methods. Your analyzing of the data, which would go into your findings, and then your evaluating of your hypothesis, which is like in your discussion and or bleeds into the conclusion. So, as you can start to see, statistics is beyond just the numerical stuff, right? It's a procedure. It's a process of data collection. What is data? It's like information and knowledge that we're understanding about the world, and we're collecting the data, and then we organize it. Statistics is a matter of organizing that data and analyzing it, and then we report on it too. It's not just the numerical side of it. We are doing this with the purpose of informing knowledge, right? Creating knowledge or understanding knowledge, rather. Statistics tends, like I said earlier, tends to be about larger quantities because it's looking at large scale representation. You're developing what's called empirical research, so research that can be supported by evidence and data, and you're using that to understand patterns and trends and social phenomenon. Um, we're going to be using the word data a lot. You've probably heard that, but essentially it's information that's collected. It's not always numbers. So qualitative research, for instance, allows you to collect data, but that's not necessarily numerical, right? It is facts, so that way you could use it for references to understand how things are and explain social phenomenon. You're producing knowledge, you're also understanding things. And then what raw data is that's data that's not analyzed at all. So folks that fill out surveys, you haven't analyzed it yet, but that's what's considered raw data. All right. So leaving off or going starting from where we left off, the important thing about theory is, we talked about theory and it may have seemed a little kind of out of place. But the thing about theory is that it explains things. It helps with explaining, social phenomenon like we talked about. It also helps with identifying relationships. And the important part about this is that you are able to develop a hypothesis, right? So previous literature and other theory really helps explain social phenomenon. It really helps to explain the whys, the workings, because it is mm, social sciences. It's really important that we understand the whys, or our best understanding, right? Correlation is not the same as causation. You may have heard that. And that means basically that what we find is that there's a relationship, but it may not cause it. Um, And theory helps us explain these relationships, right? We're looking at the linkages of things. Theory allows for the full explanation and understanding of the statistics, not just the numbers, right? If there's a percentage or an average, that's fine, but theory and literature is needed to be able to create a whole picture of the statistics. Now, in terms of the hypothesis, that's where it comes from, is the theory and the literature. And one example is when I talked about the three theories in sociology. If I'm a conflict theorist, I'm looking at it theoretically, and I see that there's a huge discrepancy between income and housing in San Diego, like cost of housing with the income that folks get. I may be able to understand this and argue this with the theoretical understanding of conflict theory, that those are folks in positions of power that kind of contain that power and those resources. Now, formulating a hypothesis is essentially a prediction. You are creating a prediction from theories in the literature. It's verified through empirical research. And what that means is that the empirical research is research backed by data, backed by resources. And you're looking at a relationship between two or more variables or characteristics, essentially. Maybe you want to look at the relationship between an individual's gender and the wage they get. Or maybe you want to look at what grades folks get depending on how many hours they study. These are all variables. And before you can even get to those, you have to understand what your variables are as well as your unit of analysis. So the way that we would understand a variable is essentially its traits. It could be your social class, which has categories. It could be characteristics, which are like race, gender, sexual orientation, religion, language. It could be educational attainment. It could be even just like yes, no. So like married, not married, things like that. This is the data you're collecting. But before you can even get to that point, you need to understand your unit of analysis. Like, what are you analyzing? What's the point? Are you analyzing people or individuals? Are you looking at groups? Like, what are you trying to do, right? What are you trying to analyze here? And that's all really important because it impacts how and why we do what we're doing, how and why we are trying to figure out everything, right? Like what are we measuring and what's the purpose? What's the intention? It also informs kind of like what types of um, literature you're going to look at. Now, when we talk about variables, we're going to talk about independent and dependent variables. And these variables are really important because this is what you're looking for the relationship between. Your dependent variable is what you're, okay, let's start with the independent. Independent variable is your causing variable, your impact variable. What this means is that like this is the variable that you can change in and out that will impact your object, your dependent variable. And your dependent variable is just that, it's dependent upon other things, outside things. So it's the thing that's being impacted. It's what's being studied, essentially. And this is the object of research. This means that this is what you are researching, right? This is the whole point of what you're researching. And that's super important because that isn't changing. Like it may, like the number of something might change, but you're not changing. You're trying to see how do other factors impact this. So here's an example. Here are your topics or your hypotheses. So one would be individuals with postgraduate degrees are likely to have fewer children than those with less. All right, so we're going to go ahead and get started now talking about the levels of measurement. So levels of measurement are important because as we begin collecting data and developing our variables, we need to be able to understand kind of which category they fit in. So essentially, you have these four. The book talks about it as three, but there's depending on who you talk about. So I like to talk about it as four because they are different. You have your nominal, which are basically categories. They can't be ranked. So there's no like order to them. There's just categories. And those would be things like gender, ethnicity, car brands, race, things of that nature. Then you have your ordinal, which has to do with categories as well, but those are ranked. So for instance, your it says here, right, like the language ability, beginner, intermediate, advanced, things of that nature. So it could be like um, class standing, freshman, sophomore, junior, senior, etc. So that's what ordinal categories are. Interval, nominal and ordinal are categorical, and they're not numbers. There will be numbers assigned to them, but we'll talk about that another time. Meanwhile, interval and ratio are numerical. So interval is something that is evenly spaced. It is ranked, and there are categories, but there's no true zero. So, for instance, days of the month, right? So it's the first day of the month. It's the second day of the month. There's no zero. They're evenly spaced. They are ranked. They're categorized. Meanwhile, the difference between these two really is that ratio has a natural zero, and that's the difference. So like height, weight, income, etc. Right. So there is a zero in the measurement. So these are kind of the four things to think about because it's important when we begin talking about excuse me, variables and how we begin coding them or thinking about them. All right. Now there's some additional variables to kind of think about as well. So there, excuse me, uh, there's dichotomous, which basically is a variable that only has two values. So it's like yes, no, one or the other. So it's like married, not married, employed, not employed. Your book talks about gender as a dichotomous variable, but I would actually argue, especially with the changes right now that the Biden administration is looking at with the census forms and such, excuse me, that a dichotomous variable that wouldn't necessarily situate here, but it's still within two variables, right? So two values. So if you had a question that was a yes or no question, that would be a dichotomous variable. Now, a discrete variable is something that has a minimum sized unit of measurement and cannot be subdivided. So number of children, number of protesters. If you think about it in terms of a number of days of a year. So like that doesn't mean that you can't divide the day in half theoretically, right? In terms of like, oh, half a day. But in terms of measurement for this purpose, right? It's something that cannot be subdivided. Meanwhile, a continuous variable has no minimum size unit and it can be subdivided. So it can be something like weight, temperature, age, time. These are all examples. So you can divide it into a smaller unit. So that's a continuous. Right? The idea is it continues, and then your discrete is that it cannot be subdivided. Now, in terms of analyzing the data, going back to the idea of the levels of measurement, right? You're a nominal, ordinal, interval, and ratio. This is really important because what happens is when we begin analyzing the data and collecting data, we have to assign codes and numbers to them to represent the data. A lot of times there's a lot of variables. There's so much data that we can't we need to be able to have some sort of organization. In a lot of quantitative studies, you'll see code books that'll assign specific codes to variables. So let's say we ran a variable around race, then the variable might literally be called 01 race or something to that effect. So the idea is that you assign a code to it. Now, sometimes you'll have to assign a value to it as well. So let's say we're looking at blue shirts as a category, right? Blue shirts would be a nominal variable, or it would be a nominal level of measurement because it's a category that can't be ranked. What we would do to run those numbers, then we would assign a number. So maybe blue shirts are zeros, red shirts are ones, green shirts are twos, etc. And it might be a little confusing right now, but we'll see it in action as we move forward. And what happens is then we begin analyzing this data and running it for statistical analysis. And generally, what happens is we're analyzing a sample to understand our population, right? So little n sample, big N population. And then what we tend to do is from there, we use descriptive as well as inferential statistics to give us information. And we'll talk a little bit more about what that means in the context of here. So the difference between descriptive and inferential is that descriptive is really there to organize and describe. So basically, your census forms, for instance, or data that collects, or if you go to like the dashboard of San Diego State, it would look at a combination of race, gender, sexual orientation, ethnicity, things of that nature. That's all there to kind of organize your who did it, what they said, the percentages of things, and to really just kind of describe the phenomenon that's going on, or just kind of foundationally your sample to describe it. Meanwhile, inferential statistics is intended to forget the sorry about that, I hadn't taken that out, this section right here. So inferential is intended to create predictions and to have inferences, right? So you're looking at how the numbers give you information for a prediction, and that is where your deeper statistical analysis would go. So an example would be inferential statistics were used very heavily to think about COVID and the impact that it would have on folks. Now, now the next stage after you've run this descriptive and inferential is you think about your hypothesis now. Is your hypothesis true? Do you need to revise it? What relationships do you see through variables, right? And then you look at your theory. Does your theory seem solid? Does it support what you're seeing? Does it need to be adjusted? Is there another theory that explains things better? All of these are questions that you would want to ask once you look at your data, once you've run your descriptive statistics and your inferential, because the whole point of a hypothesis is to create a prediction, right? So the question is then, is your hypothesis on point or is it not? The idea is like, do you accept or reject it? And that is essentially what we have for this module. And then we'll be applying it to our surveys that we're creating in class.